Okay, welcome back to a new lessons, and today we're gonna explore more about the spaceship movement. If we run again the game, in the previous lesson we saw like if we go out of the screen, we don't have any boundaries, so we can literally travel in the infinite space behind these things. It's not really realistic and annoying going out. You can see your player anymore. So we're not gonna use any following camera right now. So we need to set up some boundaries. To do this one, we need to open our player script. Below your move and slide, your function that move your character body, we can create a new variable and we can call it screen size. Now we need to get the screen size, and in order to get the screen size we can just, for example, go project settings and check your window size and copy this value over here with vector 2. We can declare here vector 2. Vector 2 is a type of variable that holds true values, so I can do like vector 2, 2 and 4. This is how to hold the value. It's not really convenient to go every time in project settings. Maybe you want to change the scale of your project and upscale it, or create a version just for Android or a version for Steam Deck, whatever. And every time go into project settings and change it and rebuild the project for every console that you want to play. It's a little bit annoying. Godot has functionality and method that you can call. It is get viewport rect. If we check at get viewport rect in our documentation, we can see how it returns these node viewport boundaries. So it's gonna understand what's the node boundaries, in this case the square over here, and now like that it returns a rect2 that is like nothing. But if we check inside the rect2, there is something called size, so we can just call get viewport rect. Our size is a vector 2, and we can assign our size to the screen size. In this way, if I print right now our screen size, let me delete this one, and I run the project, we can see our screen size match the Windows size over here. So we know that is the right settings. If I change this settings to 1200 for 700, for example, and I run the project, it's gonna be 1200 for 700. To limit the character's movement to these boundaries, we need to use things. We need to update the position of the character. So we want to update the position X, so the position of this X, to clamp. A clamp is a function that takes a value and a minimum and a maximum. So in this case, if we clamp the value between what we want and the minimum and the maximum, we can set that. We can say to the engine, okay, you need to ban this position X 0 and screen size X. So now wherever I'm at 0, the position is gonna be at 0, and whatever I'm my max position 1200, I'm gonna be in 1200. So we can give it a try by running the project. Now if I push left, I'm gonna push right, my spaceship stuck, but if I go up, I'm still going out. Now there is a reason why you're going halfway through, is because your position is based on the center of the node. So this is your position. In the next lesson, we're gonna try to fit based on the sprite. So we can do the same. If you want to give it a try, stop the video and give a try of how to update. The formula is pretty straightforward. Position Y is equal to clamp position Y and 0 and the screen size Y. So now let's give us a little bit more speed. If I run my project, I'm gonna stack between the boundaries. I can go over. Now we're gonna play a little bit more with the physics of our spaceship, because right now its movement is a little bit robotic. It's like going and stopping, going, stopping. In order to do this, we need to work with the introduce two new more values, and one is the acceleration. So how fast we're gonna reach the fast speed. We're gonna make a float. By the way, if you can do like float to declare the type, or you can just do like that, and automatically it's gonna understand what kind of variable is gonna be that. And the other variable that we need is a friction. So friction is how fast we stop compared to how fast we accelerate. So let's delete right now this here. So if we're now gonna update these things, we need a few statements. We're gonna check if the direction, so our input over here, is the direction is not, this is not, compared to this is equal to, is not, a vector 2 dot 0. So if our direction is not 0, none of them is gonna be 0, we can slide towards the max speed that we have, so our speed. We can do then the velocity is equal to velocity dot, this is a very, very important method. It's called lerp, and it wants a vector 2, so it needs to know this velocity, in which value it needs to move to. So if we have the direction is, let's say the velocity is 10 and we have 2, we want to add our direction time speed, and we want to pass also the weight, that is our acceleration times delta. Now we're gonna see what these things are. So let's say I'm stuck on 0. So right now I'm not moving. As soon as I click the direction is not gonna be anymore a vector to 0, so I'm moving. Let's write down here, check if I'm starting to move. So as soon as it understands that the direction is changing, it's gonna update the velocity. So the velocity is gonna move towards the direction that speed, as we do over here, so our max speed. And this is the weight, is how fast it should move towards this value over here. We're adding a new parameter here. This is delta. This espace over here is the times that elapsed between a frame and the other one. Is how to keep everything stable. Now we're gonna see what happens if I don't use delta. and else, so in this case we stop to move. If we're not moving anymore, if we are not moving anymore, we need to do the same, but this time we want to move towards a vector to 0, and our weight, how slow, how fast we're gonna move towards this value is our friction times delta. If you want to give it a go, just stop the video, try, but even this one is pretty straightforward. Our velocity is equal to velocity dot lerp, and we're gonna lerp towards vector 2 dot 0. This is a vector 2 dot 0 is equal to vector 2 with value 0 0. It's the same things. So we're gonna move towards vector 0, and our weight is gonna be the friction times delta. Now if I try to run the script again, we can notice how we have a friction and an acceleration. Now if I remove the delta, we're gonna see what happened. If I remove the delta, this is what happened. The updates of your velocity of your speed is not constant, so it's gonna speed up based on the power of your processor. So we revert back to delta, and here we are, a nice spaceship moving with friction and stopping. It's very simple. We can increase the acceleration. Oops, at too high value. Let's restart again. So acceleration, let's say 20. I can push to 40. We can push to 60. And we can reduce the friction to 2. You see how it slow down very slow, like if we are in the endless space. Or you can move towards, you can move towards 20. It's gonna be more of a static. So now after we saw this one, I think it's time to move forwards. We have a pretty working spaceship that can move towards space and can stop in the boundaries and can slow down and accelerate based on our time. In the next lesson, we're gonna explore how we can create a collectible element. Like, let's say we want to collect now a coin or some power up or some health bar or some fuel, and how we can communicate our spaceship with the elements that we're gonna add. We are gonna give you a hint. We're gonna use a signal. We have signals and area, and we're gonna see how we can do all of this one. So if you really like what I'm doing, try to like my video or subscribe or following me. I'm gonna try to release as much as I can every day or every 2 days, because it's really funny for me to do these things. I really enjoy, even if I have less followers.